angles. A projectile is launched from the ground at an angle of 36 degrees with a velocity of 89 meters per second. And I wrote DULP. I think what we're talking about is this. Ground, 36 degrees. I'm going to eyeball it kind of about like that-ish. I'm going to put an arrow on the end of the velocity to show that it's going that way, because I think it's very important to put arrows on the end of velocity vectors. What else can I fill in? Oh, what's the velocity?
89.
Let's put a little 89 on my little vector there. Oh, and what's the angle? Okay. Now what? We don't deal with stuff at angles. You can't, by the way, it is mathematically possible, but it's yucky math. What we're going to do is we're going to break this up into its vertical and horizontal components. We're going to say, instead of going 89 meters per second at an angle of 36 degrees, we're going to say you're traveling sideways at the same time as you're moving upwards. Why did I put an initial on the Vy, but I didn't put an initial on the Vx? Okay, the horizontal is not going to change. The horizontal calculations are always much easier, much nicer. Vertically, okay, now it's going to change. And unlike yesterday when we were launching horizontally where Vy initial was 0, it ain't going to be 0, but that's the only difference. Except the fact that it's not 0 means, you know, a lot of stuff that was canceling yesterday is not going to cancel. Okay, it's going to be a little more number crunching, which is why it's helpful if you have a calculator. So A says, find the vertical and the horizontal components of the velocity. Okay. Do a little line down the middle. We're going to use trig. The 89, opposite adjacent or hypotenuse. Let's put a little h right there. Vx. Which trig function? Cos. Nice. Cos of, the angle equals adjacent over hypotenuse. I think the horizontal component is going to be 89 cos 36. Oh, almost exactly 72. Is that right? Yes? No? Yeah? Woohoo! That's a fluke. Not often trig stuff works out evenly. Let's find the initial vertical component. I think this will be opposite. Which trig function will I use here? Sine. 36 equals Vy over 89. I think Vy is going to be 89 sine 36, which is going to be 52.31. Now, again, technically I should say 52 because that's to 2 sig figs, but I know we're going to use this, so I'll carry a few extra sig figs. I'll go 52.31. meters per second. Got me so far? Okay. What do they want me to find in part B? You know what? Now is the time to do our chart. And I think I left you room over on the right-hand side. We got a big empty space. Now we're going to go, okay, horizontal, vertical, AX is 0. AY on the Earth is negative 9.8. Vx is 72, not 89. Vy initial is 52.31, not 89. In fact, do you notice once I get the components, I'm never using that 89 again because it's yucky. It's slanty. I don't want to do math with slanty. All right. How many things do I have in each column? 2 is not enough. So I need to figure something else out. Sorry? Distance. What's my distance? First of all, which distance, vertical or horizontal? Because now we have the 2 columns. I don't think I know how far sideways. Yeah?
Your vertical distance is 0.
I got to be careful. My vertical displacement, and I always do the same thing. He's saying, how high are you when you started? 0. How high are you when you finish? 0. So what's our vertical displacement? 0. Okay. I now know 3 things. I think that means I can find, well, yes and no. Write that down, and then put your pencils down for a second. You're going to get this. 0 equals VI t plus 0.5 negative 9.8 t squared, which is a perfectly don't write that down, which is a perfectly acceptable equation. What kind of an equation is it? It's a quadratic. See the squared? The only problem is, how many t's do you have in this equation? Now, you can solve this. Actually, you can factor out a GCF and blah. You know what, though? This is one time where I say, rather than doing the quadratic, there is one more thing we know. Next to dy equals 0, I know that. How high are you when you started, Michael? How high are you when you finish? What's your velocity just as you leave the ground? Vertically. 50 point. What's your velocity just as you hit the ground? Careful. Negative 52.31. That's going to give us more options and avoid that quadratic. By the way, really what we're saying is what goes up must come down. Right? You see, now I can say, okay, I got T, and I have A, V initial, D, and VF. Can you find me a nice, easy equation that has a T in it and has some of those other things too? And I think I'm looking at the very first one. I think it's the first one that I gave you, the VF one. That's cleaner. Okay? Now, the only reason this works is because we're ending up on the ground, so you know we're coming back down at the same speed. Where this doesn't work is if you're launching from a cliff, because if you're launching from a cliff, you're going to hit the ground way faster than you left the cliff at, because you're going to keep falling and falling and falling, and that's why that one is physics 12. But here, yeah, you said, Matt, you're right, but Matt, can you get the T by itself? I think VF minus VI over A, except let's emphasize it's vertical Y, it's vertical Y, it's vertical Y. Direction, 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 direction now. And this is really why we always do vectors just before we do projectiles, because it's a good application of vectors. It's going to be negative 52.31 minus 52.31 divided by negative 9.8. Oh, I still got, you know what? I think I can go bracket negative answer minus answer. I think that's negative 52.31 minus 52.31 divided by negative 9.8. I think that'll work. Cool. I think you get, someone else try it? You get 10.67? Yep. Actually, no. 10.68 if I'm going to round off properly. I'm going to write 10.676 in my data chart, but I'll say 10.7 seconds. I'll go to 3 sig figs in my answer over here. So I'm going to say t equals 10.676, but over here I'm going to say equals 10.7 seconds, and I'll put a box around that because that's an answer. Right? Because in terms of the amount of time it's going up and down, and Matt, that's what you were hinting at earlier, that's going to tell us how long it was traveling sideways for. And I think that's going to allow us to get, well, what does Jordan C want us to find? Dx, horizontal distance. Yes? Okay, so in my chart, I'm going to go dx equals... I'm looking for an equation that has A, V, T, and D in it. Yeah, you got to wake your brains up in the morning, I know. In fact, this is you know what? Now, as far as nature is concerned, it's a horizontal projectile, just like we did yesterday. It's going to be D equals VXT. Why didn't I bother writing the plus a half AT squared? A is 0. In fact, this, put an X there, is plug and chug. It's going to be 72 times 10.676. That number times 72. And I get, whoo, boy, if that was a football player, that's a cannon of an arm. 769 meters. Basically 3/4 of a kilometer. Can a human being throw that far? No. This was some kind of a cannon, artillery. Having said that, anytime, if any of you have ever played catch with a football or a baseball, you're doing all of that calculation in your head. You're looking at where your friend is standing. You're estimating the range. You're figuring out what angle I need to angle my launch at and what VI to put. And we can do it, especially those of us that are athletic, with pinpoint accuracy. Right? You watch the quarterbacks in the NFL. They can do it to a moving target over their shoulder on the fly. This is what they're doing, complete with a quadratic equation and everything. Our brains are pretty impressive. Turn the page. Is there a part? Oh, D. Find the maximum height. You guys haven't turned the page. You're still on the same page. Is that right? Okay, so you got all your data listed. Maximum height. Height, is that vertical or horizontal? Okay. Because I've moved on to another page, I'm going to relist my data quickly. I know vertically A equals negative 9.8. What was the initial vertical velocity? 30, no, what was it? 52.31? Why can't I use T equals 10 point whatever? That's when I get back to the ground. That's not going to... Maximum height. Well, that's a dy. We're at the top. What else do you know at the top? Vertically for a split second, we've stopped going up. Now we're still moving sideways, but I'm telling you, the horizontal and the vertical components really live a life of their own. They really do. Oh, we got a latecomer. Oh, we got someone else coming in now. Just give me 1 second here. Oh, okay, now we are back. Sorry for the interruptions. Hey, do I have an equation that has A, V, D, and V initial and V final in it?
Yes.
Yeah. By the way, and the other reason I love ending the course with the projectiles unit, tell me we're not really reviewing a lot of the stuff we did from the beginning of the year. Coming back to you, I hope. Hey, Matt, do you feel up to getting the D by itself in that equation? I'll give you a hint. D equals, yeah, big hint, Mr. Dueck. Yes. That's the equation, and then I'll just remind myself vertical, vertical, vertical. Just, again, the most common mistake, kids want to put that negative 9.8, which is vertical, into the horizontal because they don't like the fact that there was no acceleration for the range. Where'd it go? You got to put something in there. So the other one is they want to use the 89. You notice, again, have we used the 89? Once to find components, and then we ditch it. We don't use the slanty velocity. It's going to be 0 squared minus 52.31 squared all over 2 times negative 9.8. Ooh, calculator practice. Curtis, my friend, is there more than one number on the top? Say yes. Is there more than one number on the bottom? Say yes. Brackets around the top, brackets around the bottom, yes. Hopefully by now this is becoming kind of redundant, but two times negative 9.8. You get 139.6 meters? Also fairly high. Okay. So our strategy is going to be, Andrew, components, and then chart list, and from there it's what are they going to ask you to find, figure out which equation, and away we go. Example 2. Here, I didn't walk you through everything. It's just saying, find the range, find dx, for a projectile launched from the ground at an angle of 57 degrees with a velocity of, holy smokes, 321 meters per second. By the way, 330 meters per second, speed of sound. So this is just subsonic. This would be some kind of a rifle or artillery shell, and it's just barely subsonic. In fact, in cold weather, that might be because the speed of sound is dependent on temperature. In really cold weather, that might be faster than the speed of sound. I don't know. Suggestions. How are we going to start? Dope. Ah, I've taught you well. Ground. Projectile. 57 degrees. 321 meters per second. Now what? Components. Vx, Vy initial. You know what? I think I'll do the components just off to the right of my picture since I have room there. This is going to be hypotenuse. Let's do Vx first. Sean, Vx, opposite, adjacent, or well, I put the hypotenuse. Opposite or adjacent?
Opposite.
Vx?
Oh,
Or which trig function? Don't say sine, that'd be a sin.
Cos.
Ah, there you go. Don't say sine, that'd be a sin. Really? Okay. Cosine of 57 equals that. So are you saying that Vx equals 321 cos 57? Is that what you're saying, Sean?
Yeah.
Because you would be correct. 321 cos 57. 174.83. Since they didn't actually ask me to find this as an answer, I just know I'm going to need this. I'm not going to put boxes around it or any of these aren't final answers, and I carry a few extra sig figs. Oh, Perry, Vy, opposite, adjacent, or hypotenuse on my triangle. I think you said, and which trig function? Cos or sin? It's a sin to call it sin. What do we really call it? Sine. Sin. It's going to be 321 sine 57. Mr. Dueck. Yeah, McKenna. I noticed, Mr. Dueck, Let me get the answer first before I go on my little rant. 269.21. I noticed, Mr. Dueck, that in the previous example, Vx was cos and Vy was sine. I noticed in this example, Vx was cos and Vy was sine. Will that always be the case? I guess if you're launching from the ground upwards? Yeah. Mr. Dueck, is there some clever, easy way that I can remember that Vy is sine, not sin? Is there some clever way that I can remember that Vy is sine and Vx is cos? I got nothing. Maybe you'll come up with something on your own, but I can't help you there at all, McKenna. Sorry. Have we got our chart? No, sorry, have you got our components? Now we go to our chart. How about green? Horizontal, vertical. I know that. I know that. Oh, and I know this. I know this. 269.21. Not enough. Ooh, because I'm starting on the ground and ending on the ground, I know something else. Yep. What goes up must come down. Who knew that was actually a physics rule? Which column do I have three things in? Okay. Of course, Elijah, you're doing math on there. There's no way you'd be texting or anything like that on your... Good. That's my only concern, is also not paying attention with some students. That, and it's too easy to cheat with those things. Matt, I think you did this before. If I recall, Matt, my friend, you said T is going to be VF minus VI over A. I'll emphasize with Y is that it's vertical, 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 vertical. Did I mention that it's vertical? Okay. It's going to be negative 269.21. Take away 269.21 all over negative 9.8. And again, I can't help noticing I have this number stored on my calculator. And so if I really want to be accurate, I'll go negative answer button minus answer button, because that is negative 269.2132523. Anyways, divided by, close bracket, divided by negative 9.8. I get a time of flight of, holy smokes, that's in the air for a long time. 54.94 seconds, almost a full minute. Well, wait a minute, we're launching something at nearly the speed of sound. It's going to be up there for a while. How's that help? I now know something in this column. And Matt, you are correct. I can now find the range. And I think that is going to be... Oh, I started writing the plus a half AT squared, and then Hakeem, I said, I don't need to. Horizontal motion, much nicer. It's going to be 174.83 times 54.94. And I get, wow, 9.6 kilometers away, 9,600. Okay. And this was the math that they were doing back in the old World War II days when they were launching artillery. You would have somebody out in the field, they would tell you the location on a map of the target, they would then actually, what you would know was the range, and you would use that to figure out what angle theta, which is a bit trickier, but yeah. Somewhat, but not really, because if it's in the air for 60 seconds, you can't predict crosswinds. You can't predict. There's an awful lot of variables there. But as long as the projectile is fairly aerodynamic, let's just say shaped kind of like a bullet. Oh, yeah, okay. Which is why they're shaped that way. And also they put a spiral on. This is why rifles and artillery, they have rifling on the inside that puts a spiral on it, so it spirals like a football. It does pretty good. I'm willing to bet you'd be within a half a meter. And, you know, what's the saying? Close only counts in horseshoes and hand grenades and artillery.
What's the weight of this shell also affected?
No, as it turns out, the masses cancel. The weight would affect how much gunpowder you needed to use to get it up to that speed, because you'd need to. That would be an energy question. You'd need to say, how much kinetic energy do I need to give it, and where's that kinetic energy coming from? The gunpowder. Okay, bigger shell, more gunpowder. Yeah, but once it leaves, a baseball will at this speed would travel the same distance as a minivan launched at this speed. Don't know why I picked a minivan, but whatever. Example 3. Example 3 we did last class. It says, projectile is launched horizontally. I would probably underline the word horizontally. From a 68-meter high cliff with an initial velocity of 85. It says, find the range. And then, what was the velocity, magnitude, and direction just before impact? That was where you found, well, you know Vx, you found Vy final, you added them together, tip to tail, and you found the resultant. That was actually the last question we did in our lesson yesterday. Hello, where are we? This one here, where we ended up getting the impact velocity. It's a lovely question, and I'm tempted to do it again, but in the interests of time and giving you time to work on your take-home quiz, I'm going to say, see last example from lesson 2. And instead, we're going to jump to example 4, physics 12. Unlike example 3, launching horizontally from a cliff, Sean, not too bad. Example 4, launching from a cliff, at an angle. See it? You know how we're going to start? Dope. I don't know why I made the angle and the cliff height the same. That's silly. I'll change that next time. 32-meter high cliff, 51 meters per second at an angle of 32 degrees. What do you think we're going to do now? Components. Vx, Vy initial. Are we launching upwards at an angle? What's Vx going to be, sine or cos? What's Vy going to be, sine or cos? Oh, you know what? Just in the interests of time, I mean, it's going to be hypotenuse, adjacent, and opposite, but Vx is going to be the velocity cos 32, and Vy is going to be the velocity sine 32. (51 cos 32), 43.25. 51 sine 32. 27.03. What's part A asking me to find? Time of flight, time for a chart. So let's go horizontal, vertical. I know AX is 0. I know AY is negative 9.8. I know that VX is, oops, I scrolled down too far. That was silly. 43.25. VY initial is 27.03. The vertical displacement, negative 32. And that is enough to find T. Put your pencils down. From here, your strategy depends. How many of you know the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a? If you're good and if you're comfortable with that, the fastest way, don't write this down, would be to do this. D equals VIT plus a half AT squared. Negative 32 equals 27.03 T plus 0.5 negative 9.8 T squared. This is a quadratic. How do I know it's got a squared? How do I solve a quadratic? Before you solve any quadratic equation, what was the first thing you had to do? Do you remember? Got to make it equal to 0. I'll plus the 32 over. And I'll get this. Negative 4.9 T squared. That's the half of the 9.8. Plus 27.03 T plus 32. And now you can go x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You can go, don't write this down, negative 27.03 plus or minus the square root of, running out of room, Mr. Dueck, equals negative 27.03 plus or minus the square root of 27.03 squared minus 4 times a, which was negative 4.9, times c, which was 32, all over negative 9.8, because 2a is 9.8. You can go from there. I'll be honest, I can do the quadratic formula in my sleep, but it's lots of typing. I would go to a quadratic solver, and I'm going to cheat right now and go to my graphing calculator's quadratic solver. I don't have it on my virtual graphing calculator, unfortunately, but I have it here on my actual TI. I'm going to go polynomial root finder, degree 2. I'm going to type in A, negative 4.9. I'm going to type in B, 27.03. I'm going to type in C, 32, and I'm going to hit solve, and I get two roots. I get t equals negative 1.00 and t equals 6. Not 5.1, Mr. Dueck. 5.2. I have no problem with that, and especially if your calculator has a quadratic solver, Sam, and some of yours do, knock yourselves out. Yep. I'll come to that in a second. Okay. By the way, if your calculator does have a quadratic solver, what I really teach my students is this. If you write the equation and you write that down, on the old provincial exam, we had to assume that you had done it by hand. If you just wrote down the quadratic formula, we weren't allowed to assume that you cheated and used a quadratic solver. I'm good with that. Use the technology. Pick your pencils up. Don't write this down yet. Here. Loop. Gone. Here is my, I think, better strategy and I think almost quicker. Find that. By the way, it's not going to be negative 27.03 because it would be negative 27.03 when the projectile crossed your eyes where you were looking straight ahead, but it's going to keep falling and speeding up. Find an equation that has A, V initial, D, and V final in it without a T. Is there one? And conveniently, the V final is by itself already, although I'll have to square root. (27.03 squared plus 2 times negative 9.8 times, and yes, Matt, it is going to be negative 32. Thank you for reminding. You are going to put the negative in there, otherwise you're going to get the wrong answer, sadly. And this one, unlike yesterday, there isn't a hint at the end that you've goofed. Yesterday we said if you forget the negative, you'd get an impossible square root. The universe was saying, I can't do that. If you're putting a positive 32, what nature is going to think is, oh, you landed 32 meters above you, which is perfectly possible if there was another cliff up there. The universe doesn't know that. This number squared plus 2 times negative 9.8 times negative 32. What do I have to do now? Square root. And you get what? And the only problem is this is technically wrong. This is the only tricky part about this method. So in the first method I showed you with the quadratic formula, the tricky part is you're typing a lot of quadratic. What's wrong with this answer? Yeah. The answer is not negative. Are you not heading down? See, the problem is your calculator, when you square root, gives you the positive answer. But in real life, right? Because negative 3 squared, is that not also 9? This is, by the way, what you're also doing is proving why a negative times a negative is a positive. We're actually finding out that nature insists that because we have to be able to take into account the fact that, hey, it could be heading down. You'll have to add that yourself. You'll have to be aware that of, you know what? It's going downwards. I have to add the negative. Your calculator won't. That's the only risky part with this. But first of all, how many lines have I written so far of work? 2. Recall, I think for the quadratic formula I had 5, yes? Now, can we find t? I think we can use the VF equals VI plus AT, and Matt, you got the t by itself earlier. T is VF minus VI over A, vertical, 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 negative 36.84 minus 27.03 all over negative 9.8. Here, 3 or 4 lines. It's a little less, I think it's less writing than the quadratic formula. The only problem is, Jordan, you have to keep your wits about you. You have to realize when you find V, first of all, don't forget to square root to find V final, and then you have to clue in, that's actually not the answer. It's going down. I have to insert the negative because I know it's going down. What do you get? Negative answer, woohoo, minus 27.03, close bracket, divided by negative 9.8. Should get a positive time, though, yes? I hope. 6.52, 6.518, I'll write 6.52, but I'll keep that number on my calculator. Now that I've found time, the question falls apart. You want to find the range? No problem. I'll go dx equals vxt. I got vx. Oh. You want to find the maximum height? No problem. I won't use any of this. At the top, how fast is it traveling vertically for a split second? I know Vy final is 0. I can find the time to go up, and I can do some math. I can do some math there. Oh, and then I'll add 32 meters because it's on a cliff. Now that I've got this, it's falling apart. But this is what takes the most work. Did I add a part B to this? Oh, by the way, does what we got match the two answers that I got with the quadratic formula? Yep. Mr. Dueck? Yeah. What does that negative answer right there mean? It does actually have a meaning. It says this. See my DULP? If instead of going forwards at 51 meters per second, if you went backwards at 51 meters per second, you would also hit the ground in 1 second. In 1.00 seconds. It's actually saying if you went backwards in time, that's how far backwards in time you'd have to go if you were starting on the ground. So it actually does have a meaning, which is kind of cool, but we're going to ignore that. Oh, here we go. Find the range. Is that on the next page for you guys? Okay. dx equals vxt. Well, I got to scroll back. What was Vx? 43.25. T, 6.52. 43.25 times 6.51791, blah, 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 blah. I get a range of 282 meters. What else am I asking you to? Oh, we're good. Last one. Is that okay, AJ?
Yeah.
Waking up? Okay. C. Find the maximum height. Okay. Height, vertical or horizontal? Since we've turned the page, let's list our vertical data. I know AY is negative 9.8. I know VY initial was, I can't remember, VY initial was 27.03. I can't use T. T is not 6.52. That's how long it took to get to the ground. Oh, and I can't just divide that by 2 like I could if I was starting on the ground and ending on the ground, because when we're doing that, we could say, oh, the time to the top was halfway. Here, since you're starting on a cliff, you were going up for less time than you were coming all the way down. But what do I know at the top, Amanda?
0.
What's 0? And I can find that. Matt's been on a roll. I think he did this one earlier for us too. It was the squared, the VF squared minus VI squared all over 2A. Yeah? Woohoo! VY final squared minus VY initial squared all over 2A. 0 squared minus 27.03 squared all over 2 times negative 9.8. $37.3. Which is wrong. No? Yeah, that we've just found how high above the cliff, because we're treating the cliff as height 0, which is why the hitting the ground was negative. So if we want the actual height from the ground, 37.3 plus 32, which I think I can do in my head, 69.3 meters. By the way, I think question C, that's fair game for Physics 11. We didn't have to pull up the quadratic form. In fact, I think I gave you stuff like that way back when we did free fall. But specifically, finding the range and the time cliff at an angle, I won't give you one like that on your test. Maybe as a bonus. Absolutely, I like this question, I like this question, I like this question for Physics 12. In Physics 12, you're going to have one of these on your test, if any of you take it next year. I didn't give you the answers this time. I noticed I wrote solve the following in your books. I was also trying to save paper. Mr. Dueck will go over the answers with you next class. What can you try? Number one, on the moon. So number one is just like we've done. We're launching from an angle on the ground, except instead of G being negative 9.8, what does the question say G on the moon is? 1.6. You all know that one of the astronauts, one of the moon landing astronauts, I think it was Alan Shepard, but I have to look it up, brought a golf club and a golf ball and famously teed off on the moon, the world's most expensive golf course. Number two, horizontally, so we've done that already. Ooh, the tricky part is C. C says, with what velocity does the rock hit? That's wanting you to come in at an angle and add the components, magnitude and direction. Number three, an earthbound golfer angle. That's a good one. Five is good. Skipped four. Six is good. 6D might be tricky. 7. 8. And then I wrote a little note here. The remainder of this sheet is probably, you can replace the word probably with almost definitely. Tougher than I'll put on the test. Try them to see if you can get any of them. Fired from a slingshot, angle of 30 degrees. That's a tough one. Fireman standing on a building 20 meters high. He finds it if he holds the hose so that the water will be... You can try number 11. On level ground, a ball is thrown forward and upward. The ball is in the air 2 seconds, and it strikes the ground 30 meters from the viewer. What was the ball's initial velocity? You can try 13. Those are nasty, and if you can't get those, no big deal. Your main homework is take-home quiz. Okay? Tuesday, I might have a review, but I won't be throwing any new homework at you. I do have a couple more quizzes to practice as well. You got 20 minutes. I think you can get the take-home quiz done in class, if nothing else. And some of you have a bunch of homework to hand in because it looks like a lot of you didn't do lesson 2 yet.